Okay, this is problem 9.77. Okay, an electric motor of mass 20 kg and an operating speed of 1350 rpm is placed on a fixed steel beam of width 15 centimeter and depth of 1.2 centimeter as shown in figure 9.53. The motor has a rotating unbalance of 0.1 kilogram meter over here, and the amplitude of vibration of the beam under steady state operation of the motor is suppressed by attaching an undamped vibration absorber underneath the motor as shown in this figure. So this is the motor and this is the absorber. Determine the mass and stiffness of the absorber such that the amplitude of the absorber mass is less than 2 centimeter. So let's say the amplitude of the absorber, which is XA, is less than 0.02 meter, which is also equals to 2 cm. And the given operating speed, which is n, I use it in this formula over here. Omega equals to 2 pi n over 60. So just substitute your n as 1350 rpm. So you'll get your omega to be 45 pi radian per second. So over here, as you can see, I have 3 steps altogether. Okay, it's a fairly simple question. Okay, starting from this part over here, stating in the question that basically you have to design, all right, to get the mass and stiffness when the criteria given that amplitude of the absorber is to be less than 0.02 meter. So if the amplitude of the absorber is less than 0.02 meter, following your lecture 18, all right, where this formula over here, where the design criteria is omega equals to omega A. Sorry about that. So omega equals to omega A. Okay, then you get your XA, which is A2 in the lecture slide. Sorry, XA. So amplitude of absorber to be negative P naught over K, which is the KA. The K for the absorber. P is your force. So this right here in this system, it is unbalanced system. So in unbalanced system, you can always change your force if you don't know your force, because in the question they didn't give you any force, right? So you can always change your force to be ME omega square. All right, ME omega square right here. See, I change it to ME omega square. So this formula X equals to negative P naught over K, this one, KA, yeah? So then alright, so then I bring P naught to the other side along with the negative. So because of that, this sign here will change to more than, okay, because you divides with negative on the other side. So we know that stiffness cannot be negative, so that's why I put modulus sign here showing that it must be positive. So change your force to ME omega square, okay, for rotating unbalance, because we don't know the force, so we can substitute that. Okay, where your ME is 0.1 and your omega is 45 pi. Okay, calculate this, you'll get your answer to be so you get your Ka to be more than 99929.7446 Newton per meter. So we want a fixed value because this is we are doing a design question. So let's say we choose it to be 110,000 Newton per meter. So that's why we choose that. So you can also choose 100,000 straight away, okay? But since Ka needs to be more than this, so you can choose any values more than that, okay? Doesn't matter. So next, the question wants you to find the mass and stiffness, right? So we've already found the stiffness. Now we're going to find the mass using the formula from your formula sheet, which is omega A, omega for the absorber, equals to square root stiffness of the absorber divided by the mass of the absorber. So use this, okay, where we are using this right just now, meaning our design criteria is omega equals to omega A. For this, the case is, or the design criteria is omega equals to omega A. So that's why our omega 45 pi equals to omega A. So the Ka that we get, that we choose just now, put it inside here. Okay, then you can find your mass of the absorber to be 5.5039 kilogram. Next, we want to make sure that our amplitude for the absorber is really less than 0.02 meter. So use this same formula again, right from here. Alright, so substitute, change your force, because we don't know the force, to be me omega square, where your me is 0.1, same value as this one, and your omega is 45 pi. Okay, now your Ka, okay, put the one that you chose just now, so 110,000. Okay, calculate this, you get your answer for the amplitude of the absorber to be negative 0.0182 meter, which is less than 0.02 meter, as what the question stated right here. So, meaning that our stiffness that we chose just now is correct, is acceptable. Also, the mass for the absorber is also acceptable. Okay? And that is all for problem 9.77.